3.3 in Advanced Algebra 1, doing a little bit of relations and functions. So what's a relation? I got it defined for you right here. It's just a set of ordered pairs, right? You'll see the word relation a lot. It's just a set of ordered pairs. And how we can represent it, we can do it in many ways. We can do it as like a set. You see that they put them in the fancy schmancy little set right here. That's a relation. We can make a table out of it. We could graph them, and we could make a mapping. Let's do all three real quick. Let's make a table of this. So do you see this very first ordered pair right here? It's 1, 1. Real simple. X is 1, Y is 1. Do you see how we're just making like a table of values for those right there? So the next guy is 0, 2. So 0 is the X value, 2 is the Y value. And then 3 is the X value, and negative 2 is the Y value. Do you see that their partners are directly across from each other, and then like they just match up? We made a table of values before, right? You know, so okay. And then to graph it, cool. We shall graph it. I don't need to change the scale because these numbers are small enough. I can reach it counting by 1. So 1, 1 isn't that right here? 0, 2, and 3, negative 2. You can represent a relation by graphing those ordered pairs. And then the really weird one is this thing called a mapping. Don't know if we've talked about the words domain and range. You're going to hear those a lot in your algebra future. Domain is fancy schmancy math talk for what can the x's be? Like what are the set of all the x's, right? So if we go through this relation up here, I'm just going to boom, boom, boom. Aren't those all the x's in this situation? So I'm going to put them in here. And if you are OCD and you have to put stuff in numerical order, it's going to be all right. I recommend not putting them in numerical order. I recommend putting them in the order that they listed them. Like 1 was first, 0 was second, and 3 was last, right? So I just think do it that way. And then we got to go do that for the range. Range is fancy talk for who are your Y values. So we'll do this. And the other thing that I haven't said yet is we don't put anybody in there twice, but nobody has shown up twice. Like 1 is in the range, 2 is in the range, and negative 2 is in the range, right? So if somebody happened to show up twice, we wouldn't put them in there. Then we'll usually use a straight edge, but I'm not going to pass those out. We put a little arrow to map them. Isn't 1's partner 1? So I'm going to draw that little arrow there. You can freehand it, you know, just draw an arrow, but it's only got 1 arrowhead on it, right? It points to the range guy. 0's partner is 2, and 3's partner is negative 2. That's called a mapping, where they're like, hey, here's my X values, and it points to its partner as a Y value, the domain to the range. Cool? So let's mess around with that. Let's try this one. Let's do this guy as a table. So negative 2, negative 1, 3, 3, and 4, 3. The tables can repeat, right? You know, you see that 3 showed up more than once in the Y column. That's totally fine. You gotta have your partner next to you in a table. When you graph it, it's all good in the neighborhood. So negative 2, negative 1, 3, 3, and 4, 3. Are we cool with that? The only weird boy is the domain bubble and the range bubble. You can't put anybody in there more than once. So in the domains, it's all the x's. Negative 2 needs to go in there. He's an X value. 3 needs to go in there. And 4 needs to go in there. Do you see those were the only x's? Nobody repeated itself. But when it comes to the y's for the range, negative 1 is a Y value. And so is 3. But 3 happens more than once. Are you with me on that? It happened again. We don't put him in the range bubble more than once. He's just in there. And when we draw our mapping, negative 2 partners with negative 1, 3 partners with 3, and 4 partners with 3. Are you cool on the setup of those guys, right? You'll see a bunch of those. You might have to make some of those on homework today on the computer and everything. All right, and then here's the real point of the day of what a function is. A function is when every element in the domain maps to exactly one element in the range. I like to get a little real life with it. Have you all used a vending machine before? Yes or no? Vending machine, you get some input. Don't you have to input something into the vending machine? It's called money, right? You've got to put that in. That's like your domain. And you have to push a button for something to come out usually, right? You know what I mean? So like if I wanted to get Doritos out of the vending machine and it said I got to hit A1, you know, to get Doritos, If I hit A1, if I hit one button, how many packs of Doritos should come out if this thing functions properly? One bag of Doritos. For every input, there's exactly one output. Would you believe that the vending machine would malfunction if I hit the button for Doritos and Doritos and Snickers came out? You might be very happy about that as the person who bought it, but the person who owns the vending machine would go, oh, this thing isn't functioning properly. Because the function, for every element of the domain, it maps to exactly one element in the range. We are going to use this mathy definition a lot. It's the first question on your homework today. Find that definition when you want to look it up. But I like to talk about it in real people talk as well. So here's mathy. Here's how it works. I'm going to look only at this. All you care about is the domain bubble. The range bubble means nothing. And here's my question. How many arrows are coming off of this guy? How many arrows? One. How many arrows are coming off that guy? And this guy? And this guy. To be a function, you can only have one arrowhead coming off of you in the domain bubble. Every element of the domain maps to exactly one element in the range. So this is a function. Is there even instructions that ask us to see if it's a function? So the answer to this is yes. This is a function. Yes. Every element in the domain, that's what we're going to write. Every element in the domain, those are the x's, that's why we only cared about that orange bubble, maps to one element in the range. Every element in the domain maps to one element in the range. Every element in the domain maps to one element in the range. I spelled element wrong, so I'll fix it. That's kind of weird, though. Let's try again. You only care about this bubble right here. -7. Is -7 cool or not? How many arrows come off of -7? One. One is cool. 0. Here's an arrow. There's an arrow. Are you with me that more than one arrow is coming off of the 0 in that case? That's bad. This is not a function. Not a function. That is like if this was a vending machine and you hit the 0 button, two things pop out. A 6 pops out and a 9 pops out. And we can't have that. That is a misfunction, malfunctioning situation. So what do we say here? Who's the bad guy? 0. 0 is the bad guy. So we'll say the element 0. And here's the important part. Where is he at? In the domain or in the range? Where's 0 at? In the domain. So the element 0 in the domain. The element 0 in the domain maps to more than one element in the range. The element 0 in the domain maps to more than one element in the range. The element 0 in the domain maps to more than one element in the range. It's only 2 examples, but the moral of the story is, in the domain bubble, you can only have one arrowhead coming off of you. And here's the weirdest one of them all, the hard guy. What do you think about 5? Discuss with a neighbor, function or not a function? What's weird about this is they're all pointing to -3, but would you believe there's one arrow coming off of this, one arrow coming off of this, one arrow coming off of this, and one arrow coming off of this. Even though they're all pointing to -3, that's still a function. And to me, I think you've seen this in our vending machines. Have you ever seen the entire top row of the vending machine? This option was like red Doritos, this option was red Doritos, this option was red Doritos, they're all red Doritos. It's like you can have that happening in the range, right? It's about the element. Button 1 would give you red Doritos, button 2 would give you red Doritos, button 3 would give you red Doritos, and button 4 would give you red Doritos. You with me that you can assign more than one button to red Doritos because we got a bunch of red Doritos in the vending machine. So this is a function. Every element in the domain, maps to exactly one element in the range. Every element in the domain maps to exactly one element in the range. You'll say that every time you say that it's a function. Every element in the domain maps to exactly one element in the range. If you say not a function, you tell me who the bad boy was. And the middle one, the bad one was 0. The element 0 does not. Cool. All right. So that's as a mapping. You do the same thing as a table, baby. You do it at a table. Who did we care about in the mapping? The domain or the range? Who did we care about? Domain. Here's how you do it in a table. You look at the domain. Are you down with the fact that those are the x's? And you do this. You look for repeaters. There's a 2, there's a 4, there's a 6, there's an 8. Do you see any number repeat itself in the table? Nope. So function or not a function? Function. And I'm going to save us all the writing. They might have you write it out on the homework. You might have to write it out on the test. But you would write out every element in the domain maps to exactly one element in the range. I'm not going to make us write it now. Does that make sense, though? Are you with me on that? So let's do that again. Let's see if this is a function. All you look at is the x column. Do you see any repeaters? -8, 3, 7, 19. Do you see any repeaters? Function or not a function? This is a function. And again, you don't have to write it. Every element in the domain maps to exactly one element in the range. And the last one of these, only looking at those. Do you see any repeaters? Do you see the same number more than once? Who is it? So you would say not a function. The element 5 maps to more than one element in the range. Are you with me on that? A function versus not a function. So this is not a function. Cool. And then the very last thing is probably one of the most popular ways you'll use it often, especially in Advanced Algebra 2, is we can do a little thing called the VLT, which you are totally allowed to write VLT. You will never call it the VLT. You know what it stands for? Vertical line test. Just out of curiosity, have you heard of that before, the vertical line test? Here's how it works. A lot of people have heard of it. They don't necessarily remember. So I can draw a bunch of lines and erase them. You don't need to draw any lines. But I got a question. When I draw this vertical line, it went through that graph. True? How many times? Once or more than once? Once. Once is good. If you touch it once, it's going to be fine. How about this? If I drew a different vertical line, did it touch it once or more than once? How about this? Once or more than once? Here's the question. Is it possible for me to draw a vertical line on this particular graph and have it go through it more than once? Every one I've drawn so far is once. Are you with me on that? Why not this? That's a horizontal line. Are you with me on that? It's not called the horizontal. It's called a vertical line test. So you have to draw only vertical lines. If you only touch it once, you are a function. So what do you feel about this guy? Function or not a function? So we'll write it. And then here's how we'll explain it. Instead of saying that long phrase as before, since we have a graph, this is the only time we could say it, we'll say the graph passes the vertical line test. But you can write VLT. Right? The graph passes the vertical line test. But please don't say it. I hate when people go, it passes the vertical line test. I need you to say the graph. The graph passes the vertical line test, which you can totally abbreviate VLT. We just say it out loud as vertical line. Use capital letters when you do it also, please. VLT. Cool? So how about this guy? If I draw a vertical line, how many times does it touch that graph? Once or more than once? Like, I don't care that it's twice, because it could be 3 times, it could be 5 times, it could be 1,000,000 times. Once or more than once. This is not a function. Not a function. Not a function. And instead of saying the graph passes the VLT, what do you think we'll say? The graph fails the VLT. The graph fails the vertical line test. Cool? Do you understand what I would like you to write? I don't think we need to write it all the rest of the 5 times. Do you understand what I'm looking for you to write? The graph passes the vertical line test or the graph fails the vertical line test. On quizzes and tests, you'll have to write it out every time, though. Does that make sense? So let's try a weird boy. We're not used to some of these little slippery little snakes. So what you can do is take a straight, when you do the vertical line test, use a straight edge. You know, if you're going to draw out some lines, do it right. But since I can draw them real easy, how many times does that guy touch it? Once or more than once? Once. I'll just keep going. Do you think I could draw one that touches that graph more than once? And the weird part is you're just unsure of what's happening here, because you know that arrow means it's going to go up forever, right? But what you are unaware of, it also gets wider and wider and wider and wider as it goes up forever. So what will happen is it will only touch once in that spot, once in that spot. We're just not used to seeing these cubic graphs. You know, that's what it is. That's a cubic. So what do you think? Function or not a function? That is a function. Why don't you pause the video and try the rest of those graphs using the vertical line test. Cool. So come back in a second. Some of these are pretty weird, especially the next one. It's like, what do you mean go through the graph? Like, this doesn't even work. That vertical line right there, it touched the graph nowhere. Are you with me? Isn't the graph just the dots? So you kind of got to make your vertical lines go through the graph. I'll try my best to not miss, but do you see how it went through that dot right there? How many times did it touch the graph? Once or more than once? Once. Here. Sorry, I missed a little bit, but my stylus, like I have told you many times, is off a little bit. Once or more than once? Yep. And then right there it would have went through it once. Right there it would have went through it once. Right there it would have went through it once. Function or not a function? Cool. That is a function. But that was a weird graph. I'm going to change it. I'm going to put another dot. What if I put another dot right there? Would that have passed or failed the vertical line test? Because even though it passed here, 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 it failed right there. So that would not be a function. But this one was a function because that dot was not there. So that brings me to this one. How many times? Wow, that's not a vertical line. How many times does this vertical line touch the graph? Once or more than once? Once. It's not about finding that. It's can you find a spot where a vertical line would go through the graph more than once? Like right here. How many times does that vertical line go through the graph? Once or more than once? So function or not a function? Cool. Not a function. The graph fails the vertical line test. How about this dude which doesn't have a number? Function or not a function? And once you get good, you probably don't need to like draw vertical lines. You can just kind of see it, you know. So that is a function. But the question of the day, this is a vertical line. Does a vertical line pass or fail the vertical line test? Pass? Okay, let's see. I'll draw vertical line right here. How many times did it touch the graph? Never. It didn't touch it. Don't I got to touch the graph, right? So it's got to be right here. If I could get right on top of it. Pretend that was a perfect vertical line right on top of it. Does that touch the graph once or more than once? Well, does it touch it right here? Yes or no? Yep. Does it touch it right here? Yep. Does it touch it right here? How many times does it touch it? Starts with an I. Somebody said it also. Infinitely. Function or not a function? That is not a function. Right? Not a function. The graph fails the vertical line test, which is weird because it's a vertical line. A vertical line will intersect a vertical line an infinite number of times. Right? So that is like this. If I made a mapping, this is, say, 1, -4, 2, 1, -4, 1, -3, 1, -2, 1, -1. Do you see how the x, I got that all backwards. It's like -4, 1, -4, 2, -4, 3, -4, 4. Do you see how the x value is always -4 in that case? That is not a function. Last thing of the day, function notation. It came up a couple weeks ago when you're like, what is this on my homework? Like instead of a y equals, they had this f of x. Take a wild guess what the f stands for. Function. This is called function notation because they're just straight up telling you. Instead of using a y equals, they use f of x, letting anybody and their dog know if you graph this, it would pass the vertical line test. It is a function in that case. So they're asking us to find f of 4. Well, they usually use f for function, but they can use any letter they want to. Sometimes they use g's, sometimes they use h's, sometimes they use like q's. It's like all kinds of stuff. You see they have given me 2 functions in this guy. I got, sorry, that's not a highlighter. I got f of x in green, and I got g of x. That's how you say it out loud with the parentheses. It's weird because you'd think that means multiply stuff together. It does not. We'll say it once. I'll say it. You say it. This is said f of x. How do you say it? Thank you. They're asking us to find f of 4. And here's the real easy part once you get used to it. If it was written like this, you see that what's inside parentheses is an x value, correct? When they want you to find f of 4, do you see that there is a 4 in the spot where x was? All you simply do is take this equation and substitute 4 in for x. So we'll write it all out though. So we'll start like this. F of 4 equals 2 times 4 minus 4. Do you see that what is in this circle right here is literally the same thing, except where there was an x, I have put a 4 in its place? Yes, no, maybe? Are you with me on that? Here's the part. There is nothing you can do right here. Absolutely nothing. F of 4 will remain f of 4. And let's clean the right side up. What should I do first according to the order of operations, this multiplication or the subtraction? So that is 8 minus 4. And what is 8 minus 4, baby? 4. F of 4 turned out to be 4. That is fancy schmancy talk for what is the function evaluated at 4 turn out to be. So we put 4 in for x. Which function should I use on the next one? The g function or the f function? G. So let's do this. Let's rewrite it. G of 2 is going to equal, ready? Let's take a shortcut if you trust me. Will you trust me on this? Parentheses mean everything. If you do not use parentheses with many of these problems, you will probably get the wrong answer sometimes. But if you use parentheses every time, you will be guaranteed to get the right answer. So here's what we'll do. Back in the OG, I'm going to put parentheses around every x that I saw. That's the real secret to success. And if you would like to learn the hard way, don't use parentheses. Are you with me on that? I'm not trying to be mean about it. Done it for many years. It's like, how come I got this wrong? How come I got this wrong? Because you used parentheses incorrectly. So check me out. I am going to now put 2 in for x, and it needs to go in the parentheses. So, sorry that I hit the wrong button right there. We are going to rewrite it like this. Did you see where there was an x, I totally put 2 into those parentheses. Yeah. And here's why I'll let you cheat it. Punch it in your calculator now. And if you totally use parentheses, you will always get the right answer. Of course, if you hit the right buttons, too. You know, you got to hit the right button. Sometimes you hit the wrong button. But totally use parentheses. It will guarantee to give you the right answer. You see how I literally typed that in? What did you get? -4 is correct. -4. So you don't need to do any of that work. We'll just say g of 2 equals -4. I need to see 2 things. 1, you subbed the number in properly. 2, you punched it in and got your results. Cool? So I'm going to only do one more, and I'm changing it. I'm changing it. I don't want to find f of -5. I want to find g of -5. Are you with me on that? Let's find g of -5, and I will challenge you to do it properly. Go for it. Put -5 into the g function. Do you have an answer? Can you shout it out for me? What did you get? 45? Okay. Whoops! I didn't get 45. Why not? Because I didn't put -5 in parentheses. But if you do put -5 in parentheses, you will get the correct answer. I didn't put a -5. Let me try that one more time. My button didn't get hit. Of 45. What's the difference? Well, obviously you know it's the parentheses. Look right here. What's being squared? 5 or -5? -5 is being squared. And a negative times a negative is what kind of number? Positive. But if you don't tell it to square -5, it's only going to square 5 right there, because your calculator is programmed to follow the order of operations, and the number being squared is 5. And then it takes it times -1 after that. Most students do not understand what I am talking about right now. But if you would trust me that if you use parentheses, you will always do this correctly. Does that make sense? Whatever you are substituting into needs to go into parentheses, because this is squaring 5 and this is squaring -5. Are you with me on that? So cool with that? Use parentheses. You'll get it right every time. Awesome. Let's do some homework.